Today, a discussion with SA Studbook on genomics and the livestock breeder. And joining me today is Jason Redding. And when we talk about genomics, it's usually Jason. Welcome again.
Thank you for having me.
Jason, how can genomics illustrate population dynamics between different cattle breeds and within breeds?
Well, first we have to start at what are we trying to illustrate? If we go back to the SASAS Congress in 2021, the theme of that Congress was, is science communication reliable and responsible? And is it effective, and can the farmers understand what we are trying to indicate to them? So I had a poster at this conference, and it was about a gene box, which is a brainchild of Dr. Bobby van der Westhuizen and Dr. Donna Berry from Ireland. And it's kind of become my little project now and what I do at work. And what it does is it helps us visualize the population dynamics between all of the breeds. So it's a 3D box that will show the depth as well as the range of diversity within breeds and between breeds. But how do we communicate this gene box and the methods behind it? Principal components analysis, genomic relationship matrix, those sound very high level science. And I have technical advisors that I work with, and they say, you talk too high level. Bring it down a bit to a practical level. So after working with this gene box for a couple of years, I think I have got a really good way of communicating it. So there are 3 ways that we can differentiate a cow. The first way is its origin. Is it of taurine origin, the European breeds like a Sussex or a Charolais or a Hereford? Or is it of an Indocene background, the humped cattle like a Brahman or a Gur or a Boran? So you will see that in the gene box that the Indocene breeds are all the way at the top and that the taurine breeds are all the way at the bottom. And in between them are the composite breeds, which are have been bred from both Indocene and taurine backgrounds, such as the Beefmaster, Bonsmara, Huguenot, Santa Gertrudis, as well as the naturally occurring Sanger breeds that we have, our indigenous breeds, which are an admixture of both Brahman and taurine breeds from ancestral populations, and then through the Bantu people moving down through Africa, they've isolated those populations, and that's what they have created. The second thing is we have selected cattle for either being beef producers or dairy producers. So in the gene box, you will see that there are a variety of colors of clusters, and there are the blue clusters are the dairy breeds. You have one on the right and one on the left. One has been selected for higher volume. One has been selected for higher milk, the products within the milk, for milk fat and milk protein. And then we have the normal dairy breeds slap bang in the middle, right next to all the other Taurus beef breeds. The red breeds in the middle are all the composite breeds, and you can see that they have the most variation. Their clusters are the largest because of the contribution of more than one ancestral population to the genetic diversity in this breed. And that size of the cluster is the third component that we can tell breeders about, is that breeders know that an animal can be of the same breed, but their diversity is different because of either the environment that they exist in. Compare the Karoo to the Western Cape. Those environments are completely different, but you can have the same breed of animal existing there, but they look different. And the second one within the diversity is the selection practices that breeders have placed on their own individual herds, and also maybe the background of these animals. In the upgrading process, we know with composite breeds, we can upgrade other beef breeds to become the composite breed. So depending on the breed you've upgraded with, your herd or your animals will lie in a specific part of that cluster.
Jason, explain to us, stud breeders who genotype their animals, they receive a percentage value of how related an animal is to the rest of the breed. So why is this done, and what's the current and potential benefits of this?
So we call that the breed key. So we've just talked about these clusters, And you can see by those clusters that specific breeds have specific types of genetic diversity. So Donna Berry from Ireland had an idea of, wait, but can we not calculate a score for each of those clusters? And then we calculate the score for an animal, and an animal's score should relate to where it falls within that cluster. So at the moment, we provide it to breeders so they can see how related to the current genomic population is their new genomically tested animal. The potential with this breed key lies specifically in the upgrading process. I just spoke about animals from different breeds can be upgraded to a composite breed. And that takes about 4 or 5 generations as the animal goes from being a section A to a section B to a section C, and then only being SP because of the Mendelian inheritance of crossing consistently with the pure breed. But now if we test genomically, we can actually see, but this section B animal that is supposedly 75% of the stud breed that the breeder is trying to get to is actually 90% related to that breed, meaning that we can potentially upgrade that animal to be a section C or even an SP animal and not penalize these animals just because of the current process of upgrading that is occurring. And then the last one is with regards to rural communities. There's a lot of funding going on by the ARC at the moment where they are genotyping animals within rural communities. And the animals within the rural communities, their breed composition is not known. We don't know what other breeds have been mixed over the generations that these rural communities, they've brought in different bulls. So now these rural community breeders will be able to receive this score, and it will tell them what composition of each breed, because we don't just compare it to the breed that the animal that the breeder is telling us it is, we can also compare it to all the other breeds. And sometimes we pick up an animal that the breeder says is SP, but it's only 50% related to the breed that the breeder is breeding stud animals to. And then we can see, oh wait, it's 50% of something else, meaning maybe a bull jumped the fence and got lucky with one of the cows, and now your SP bull that you think you have is not an SP bull.
Jason, continue what you're doing. It's fascinating and very relevant, and I'm sure our farmers out there appreciate the feedback you give them on genomics. Well done. Thank you very much, Jason Redding from SA Studbook.